Here is an exercise of drawing the Newman projection given the projection in terms of Fisher. We have already seen in the Fisher projection formula, the convention is horizontal bonds are projecting forwards and the vertical bonds are going backwards. Another important convention is the Fisher projection formula is given only for the eclipsed form. That is, if you are given the Newman projection formula, you first have to make it eclipsed by rotation and then convert the eclipsed to Fisher. The converse is, if you are given the Fisher projection formula, remember it only represents the eclipsed form. Since the two COOH groups are going away from you, we represent the two forms by dotted lines. The thick lines or the CH and the COOH bonds are projecting forwards. Since this represents the eclipsed form, we have to draw the Newman projection in such a way the hydrogen eclipses the other hydrogen, the COOH bond eclipses the other COOH bond, and the COOH groups lie exactly in a line. So, the first form gives the eclipsed form. But generally, the staggered is the more stable form. So, by rotating the front carbon, we take one of the COOH upwards. So, the second form gives the staggered form of mesotartaric acid. Note that in the Fisher projection, we have shown already a dashed line representing plane of symmetry, which makes the compound optically inactive. The eclipsed form truly gives the plane of symmetry, the plane that bisects the bond between carbon 2 and carbon 3. In the staggered form, we have the center of symmetry. That is, if you draw a line connecting the two COOH groups, or draw a line connecting the two OH groups, or draw a line connecting the two hydrogen atoms, all these will pass through exactly the center of the carbon-carbon bond marked by carbon 2, carbon 3.